Have you ever wondered how a rocket works? It's a question that has puzzled many, and today we're going to delve into it. We're about to embark on a journey that will simplify the intricate science that fuels these magnificent machines. Rockets, these towering symbols of human ingenuity, are more than just metal, fire, and smoke. They are a testament to our relentless pursuit of knowledge and our unyielding spirit of exploration. From the humblest firework to the most advanced spacecraft, rockets are a marvel of science and technology. They harness the raw power of physics to defy gravity, reach incredible speeds, and travel to distant worlds. Today we will peel back the layers of complexity and break down the workings of a rocket into simple, understandable parts. We're about to embark on a journey that will take us from the launch pad to the furthest reaches of space. So let's dive in and uncover the science behind rockets. First, understand that rockets move by a certain principle. This principle is none other than Newton's third law of motion. You might be familiar with it. For every action, there is an equal and opposite reaction. In the context of rockets, this law is crucial. Think of it this way. Imagine filling a balloon with air and then letting it go without tying the end. The air rushing out of the balloon propels it in the opposite direction. That's pretty much how a rocket works. The rocket fuel, once ignited, expands rapidly and is forced out of the rocket's engines. As this happens, the force of the fuel's expulsion propels the rocket in the opposite direction. This is the principle of rocket propulsion, the idea that the expulsion of one thing can propel another thing forward. It's a fascinating concept, and at its heart is a simple law of physics. This principle, simple as it seems, is the fundamental force that propels a rocket. Rockets, though, aren't just about force. They're complex machines with many parts. Each of these parts has a specific function, and together, they make the incredible feat of space travel possible. Let's start at the top with the nose cone. This is the pointed front part of the rocket. Picture it like the tip of an arrow. It's designed to minimize air resistance and helps the rocket to move smoothly through the atmosphere. Next, we have the payload. This is like the heart of the rocket. It's the reason why the rocket is being launched in the first place. The payload could be anything from a satellite, a spacecraft, or even supplies for astronauts in space. Whatever it is, the payload is the precious cargo that the rocket is designed to carry. Moving on, we encounter the fuel tanks. These are like the stomach of the rocket, storing the food it needs to work. In this case, the food is the rocket's propellant, a mix of fuel and oxidizer which provides the energy needed for the rocket to escape Earth's gravity. Then we come to the engines. These are the muscles of the rocket, providing the power needed to lift off. The engines burn the propellant from the fuel tanks to produce a force called thrust. Thrust is what pushes the rocket upward, defying gravity and allowing it to reach space. Finally, we have the fins. These are like the rudder on a ship, helping to guide the rocket on its path. The fins provide stability, ensuring the rocket maintains its intended direction throughout its flight. So, you see, rockets are more than just big tubes filled with fuel. From the sleek nose cone cutting through the air, to the powerful engines providing thrust, to the tiny fins keeping the rocket stable, every piece has a role to play. Each part of a rocket has a specific function, all working together to achieve the goal of space travel. The launch is a symphony of science where every element must perform in perfect harmony. Now, let's dive into the fascinating process of a rocket launch. Everything begins with the ignition, the spark that gives life to the journey. The rocket motors come alive, burning fuel at an astonishing rate to produce a tremendous amount of thrust. This is the heartbeat of our Symphony, the steady rhythm that propels the rocket forward. As the motors roar to life, the launch clamps release their grip, and the rocket begins to ascend. This is the crescendo, the moment of truth when gravity's hold is defied. The rocket, this magnificent creation of human ingenuity, ascends with a fiery tail, piercing the sky, painting a bright streak across the canvas of the cosmos. The first stage, the largest part of the rocket, burns its fuel and falls away. It has played its part in the Symphony, providing the initial thrust needed to break free from Earth's gravitational pull. It's like the opening act of a grand concert, setting the stage for the spectacle to come. Next comes the second stage, smaller yet equally vital. It ignites, providing the continued push needed to reach the desired altitude and speed. It's the melody that carries the Symphony forward, the steadfast progression that brings the journey closer to its climax. Once the rocket has reached the right speed and altitude, the second stage engine cuts off. It's now time for the payload, the reason for this grand symphony, to play its part. It separates from the second stage and enters its desired orbit, completing the journey. This is the grand finale, the climax of our symphony, where everything comes together in a harmonious blend of science and engineering. Every part of the rocket, every stage of the launch is a note in this symphony of science. Each plays its role, contributing to the grand spectacle that is a rocket launch. And that, in essence, is how a rocket launch works, a marvel of human achievement. So what have we learned about rockets? Well, we've journeyed into the heart of these incredible machines, exploring from the ground up. We started with the principle that powers them, action and reaction. It's Newton's third law at work, where every action has an equal and opposite reaction. This simple principle is the foundation upon which all rocket science is built. From there, we delved into the different parts of a rocket, each with its unique function. The engines, the fuel tanks, the guidance systems, all integral pieces of the puzzle that is a rocket. Then we witnessed the magic of a launch, a symphony of science and engineering. The countdown, the ignition, the liftoff, every stage meticulously planned and executed, a testament to human ingenuity. Next time you see a rocket launch, remember the incredible science and engineering that makes it all possible. Until then, keep looking up, because who knows what you might discover.